Okay. Hi, everyone. Welcome. Welcome to our session on cross-cutting perspectives on active learning among researchers and practitioners. My name is Preeti Raman. I'm from the University of Toronto, from OISE, the School of Education. I'm the chair of this session. This is a symposium session that you're here for, and this symposium examines perspectives of active learning through 3 presentations that comprise of 1, an analysis of active learning activities designed by practitioners. 2nd, investigations into the typologies of orchestrational flow in active learning classrooms. And 3rd, a preliminary synthesis of research findings of active learning approaches and strategies in the learning sciences. Now, the purpose of this symposium is to advance the discussion of active learning, its definition, vocabulary, practices, and assumptions. Therefore, we see the symposium as the first step to create this kind of dialogue and discourse among researchers and practitioners. So welcome. Now, we have 3 presentations in this session, but before we begin, there are a few things I need to share. 1, I told you the session is being recorded. So if you feel uncomfortable, well, we're all instructors, we've been there, but if you feel uncomfortable being recorded, please consider switching off your camera, renaming yourself. Your privacy is yours. We are using closed captioning, so feel free to hide the subtitles by clicking on More and Hide Subtitle in your Zoom window. You can turn them back on at any time by clicking on More again and Show Subtitles. Okay, now our first paper is a presentation. It's a preliminary review of active learning approaches and strategies in the learning sciences. It gives me great pleasure to briefly introduce my colleagues, my friends from Toronto, from the University of Toronto. Joel Wiebe is here with us. Joel is a PhD student at the University of Toronto. His research interests relate to active learning and learning communities. Currently, he is developing active learning patterns for higher education mathematics context. Garrick is here with us. Garrick is a current MA student at OISE with interests in classroom design, technology integration, and STEM pedagogy. He's also interested in how we can build better technology that seamlessly supports teachers in their existing pedagogical practices. His previous work at the University of Alberta focused on how effective pre-service STEM teachers are at finding resources online and what type of resources they selected and why. Our third presenter is Rubina Khan. Rubina Khan is a PhD student at the University of Toronto. Hi, Rubaina. Her research interests lie at the intersection of engineering education, learning communities, and curriculum studies. Prior to her doctoral studies at the University of Toronto, Rubaina taught systems engineering and designed active learning classrooms. Okay, Joel, I'm gonna give the stage to you.
Perfect. Can everyone see the slides okay?
Looks good.
Wonderful. Yeah, so our presentation is the first in the symposium on cross-cutting perspectives on active learning among researchers and practitioners. So ours is focused on that preliminary review. Yeah, there'll be 5 different sections to this presentation. We'll give a brief introduction into the topic, discuss some of our research questions, go over the methods, discuss some of the preliminary findings, and then discuss a couple of the main themes and then the next steps. So the big question that drove this study was essentially how can the learning sciences, which is a field that I'm going to introduce right away, but how does this field of the learning sciences and active learning inform one another? And so in this graph that everyone can see here, or in this timeline, I've split it essentially. The top shows kind of a progression of some of the scholarship of learning. So before 1980, the science of learning was divided into many different fields, and a lot of the science of learning would be restricted to a single isolated study, either cognitive science or educational psychology, neurosciences, instructional design, or many of these other fields. Around this time and a little bit before, but progressing into this, was this notion of an evolving new science of learning. And this new science of learning believed that traditional instructional practices were flawed, essentially that memorization of facts and procedures was not enough. So by 1991, all these individual disciplines came together, and there was something called the learning sciences that was formed. And the goal of the learning sciences was to redesign real world classrooms and learning environments to support deeper and more effective learning. So essentially, they wanted to understand the cognitive and social processes of learning. And on the bottom side of the timeline, we see kind of the evolution of classroom practice toward active learning, where around the 1980s, there was a growing anecdotal evidence for the benefits of hands-on learning as well as student-centered learning. By the 1980s, there was an emerging combination of lecture and lab formats into these more studio approaches. Around this time, there were also the design of active learning spaces, which are spaces that facilitate or support active learning pedagogy. Similarly, around this time, I think approaching the later 1990s, was the development of some new instructional approaches, such as peer instruction to support active learning. Progressing to the 1990s, we see a growing popularity of flipped or inverted teaching and learning, as well as increased research evidence for the benefits of active learning. So essentially, we have these two different communities. We have the community of the learning sciences and community of active learning. And so the learning sciences is often constrained to research contexts, while active learning is primarily adopted by practitioners. So even though they are distinct communities, they both examine similar grades, including K-12 and higher education. They both take place in real world classrooms, and they often target 21st century skills. So we figured that this created an interesting opportunity to think about how these two different communities can overlap and inform one another. So the research questions that this brought us to were, to what extent are active learning approaches and strategies researched within the learning sciences? And to that point, what are some of the empirical findings? In addition, what ways can the learning sciences research inform practices and instruction of active learning approaches and strategies? So essential, what are the practical implications? The method that we chose for this is a scoping review, and a scoping review essentially takes a large body of literature, so many individual studies, and combines the findings together in a way that summarizes them and makes them more accessible. And this often takes the shape of 5 different stages, starting with identifying a question, identifying relevant studies, selecting from those studies the ones that we want to examine, extracting predetermined types of information, and gathering it together. So in our case, we had this question about what are the active learning approaches and strategies within the learning sciences. We took 2 of the learning sciences journals, and we used actually the Salties, so that on the Salties website, we used the active learning approaches and strategies to query these databases to find the studies that were relevant to active learning approaches and strategies, and selected those studies that had empirical findings. And we're currently in the process of pulling out some of that relevant information. And this is a preliminary presentation on what we have found so far. So essentially, we found that 23% of these articles pertain to active learning approaches and strategies. And from those, 83% had relevant empirical findings. So this is how it charts out. We did an examination at this point of the abstracts, and viewing the abstracts, we found that there were 52 that talked about inquiry, or that applied inquiry-based learning. There were 40 that applied debates and argumentation, and 20 that applied problem-based learning, and those represent these 3 major approaches. And you can see the rest were researched to a much lower degree, but those include things like concept mapping, peer assessment, portfolios, gamification, problem-based instruction, case studies, and jigsaw. So in order to answer, so that answers our first question in terms of to what extent they are researched within the learning sciences. The next, we want to take a quick look at what are some of these, or how can they now inform some practices and instruction. So we'll look at some of the findings that we have found so far on the major 3, starting with inquiry. So I'll hand it over to Garrick.
Hi, So inquiry, we'll talk a little bit about defining it first. So inquiry is a little strange in that it can be quite broad in the way that it exists, both within the learning sciences, but also in overall classroom practices. So on the right here is sort of an image I ripped off from the Queen's University website, but it gives us our sort of 3 or 4 basic principles of inquiry or learning, which is formulating questions, researching those questions, evaluating whether or not our research and our knowledge has answered our questions, and then going through the process of reformulation. It's intended ultimately to mirror scientific inquiry. So that's its overall goal. It can exist as a near total case, so where the teacher has handed off everything to their students are defining the questions, they're discussing their questions. And this is the classic knowledge building done by Escarmilia. Or it can be a more directed form. So the teacher can define a topic that the question has to be directed to, and then ultimately the students make the decision about how they're going to address that topic, or what kinds of questions they're going to have about that topic, and ultimately the steps that they want to make to address those questions. Next slide, please, Jen. Thank you. So some trends in the learning sciences here is that overall it's found to be a benefit to student learning. So there's no evidence that it's a detriment. Inquiry-based instruction is especially effective for students who are predicted to be lower achievers. So this was actually based on a group of science and mathematics students. So they were looking at women and people of color who tend statistically to be lower achievers, or historically did. And in inquiry pedagogy, the results were much better for that type of student. And for those of us who have to deal with standardized assessments, the evidence shows no detriment to performance of the assessments, which includes the more traditional style of assessments, such as multiple choice. It does imply that inquiry tends to produce more flexible understanding in the students. So rather than having specific knowledge requirements, they have a much broader understanding of the topic. And so they're much more able to make decisions about assessments that otherwise they might find difficult. This last point here is interesting. Teachers can unintentionally sabotage active learning by focusing on assessment rather than learning as the goal. So when we talk about this type of pedagogy, you can pick up an inquiry lesson and then accidentally trash it by trying to change it so that you're focusing on the assessment rather than the way that the students are working towards the problem, or the way that they are defining the questions. Next slide, please. So an example to help you sort of visualize this a little bit. Students aged 6 to 7 were learning physics through play in an augmented reality environment. So they created a board, and the students had to imagine themselves, and this was a life-size board, the students had to imagine themselves walking along this board as a ball. And each type of tile on the board had a different type of friction. So they would have like a smooth tile, and the smooth tile would have less friction. And then they would have impulse arrows to show how much force that was being placed on that ball. And so these are very young kids, and they, through looking at how this board was set up, they were able to understand how friction worked, and also how impulse worked, which for most people in the room, especially if you teach physics, these are fairly high level learning outcomes, usually deferred until high school. The important part here is that it was triggered by the student curiosity about a mail sorting machine that they had seen in a previous field trip. And so the teachers and the researchers ultimately built this game to help address the questions that the students had had as a result of their field trip. And then the students were shown to think through how they would respond. They were encouraged to speak their ideas out loud and talk and discuss with each other, whether or not they were right or wrong. And that's actually one of the critical things, is they will say stuff and it's totally wrong. But that's not the point. The point is that they're saying it and they're speaking out loud and they're making their learning public. Next slide, please. So the lesson structure that flows out from that study, but is pretty much present in every inquiry study that I've seen, is that a lesson is paired with curiosity that the students have expressed earlier. So if you're doing this as a teacher who's trying to direct it, providing a topic and they're going, come up with questions to do with this topic, is a great way to tease out these kinds of questions, these curiosities that the students might have about the topic. And those questions ultimately drive their learning. The initial activity is focused on drawing out student thinking. So you as a teacher are trying to get them to come up with their questions. When they find the answers to some of those questions, or they start to think through those questions, you as the teacher are trying to draw out their understanding through questioning. Importantly, you're not correcting them. So if they're wrong, that's fine. The goal here is to get them to say what they're thinking out loud, and hopefully have other people in the room have different ideas and have those agreements and start to contest and think about it. Students are then shown the answer, which is what happened in the previous one, where they showed the model and the model showed where they were right and where they were wrong. And then students ultimately engaged with each other in, well, if this is what happened, this is probably why, and they did a back and forth, back and forth. Throughout the entire time, the researchers and the teachers are sitting there asking them questions, but they're never giving answers. They're always making it very clear that they're there to talk to them and to help guide, but they never provide the answers. And so the student understanding comes from themselves and comes from the discourse between each other. There is no, ultimately the experts in the room are not providing their expertise. So results. Up to two standard deviations of improvement between a pre and post test for 91% of the students. So in a world of standardized assessment, so I stole what the standard deviation was from the Alberta diploma. 2 standard deviations would be roughly a 20% gain in student efficiency for understanding those topics. So that's quite the jump. Typically in the literature, you see something close to about 5 to 10, but that's quite the jump. So we will next move on to Rubaina, who will be talking about argumentation.
Rubaina, you have 2 minutes. You're at 13 minutes and a bit.
Whoops.
All right, I will talk through this. So the next thing that we've seen, the strategy that was often used were debates and argumentation. So as you may know, a debate is a knowledge-based argumentative interaction where argumentation in interaction is engaged in order to answer specific questions purely through usually verbal means. But this is not restrictive, especially in the readings that we've seen through. It's not particularly only meant for verbal means. There has been asynchronous debates and so on. So the quality of argumentation can be described in often 2 dimensions. One is, of course, constructing the single argument, which usually emphasize the individual aspects of argumentation. How are you making that argument based on the topic at hand? And then the next part of that dimension is the construction of argumentation sequences. So this is the fun part where you want to look at the mechanism. So focusing on how these construction of sequences are made and where are the emphasis on how mutual references are made during argumentation. And then, of course, how counter arguments are made with the learning partner or partners. Next slide. So some of the trends and findings that we've seen through these papers that, explicitly said that they used debates or some forms of argumentation were that the topic of interest. So the topics of interest tended to be where, students had to come up with their own opinions about pressing issues like immigration policy or agricultural quotas and stem cell research. So I think that's that is a defining thing about what kind of topic would you want to choose for a debate or an argumentation where students would be engaged to participate. Another interesting thing about most of these journal, the second journal that we looked at was CSL, where they look at collaborative technologies. And what interesting part was that the digital tools that were used was and it wasn't to show that, you know, we can make the argumentative experience better, but rather they were used to scaffold the debate process, and then also to look at the mechanisms, like to later analyze how that argumentation proceeded as you know, the debates were happening in the classroom or in the asynchronous activities.
Rubaina, I'm gonna have to ask you guys to wind up in about a minute or so.
Okay, so I'm going to just talk about that. The argumentative activity was mainly showing students to, you know, to recognize whether their arguments were shallow or not. I'm going to move it to Joel so he can touch on PBL.
Awesome, thanks. I'll try to go quickly here. Yeah, so PBL is a form of inquiry learning that involves students engaging in complex real-world problems, such as those they would experience in their future careers. So a very common area for this is medical school, where students take on cases of actual medical patients. This has been going on a long time, since probably going back to the 1960s. Some of the main findings coming out of this, yeah, it often supports conceptual and cognitive skill development. Some recommendations are, in order to promote transfer, it's good to include reflection, and these can be connections between current, past, and future problems. Assessments should not be assessing now the individual skills, but the most accurate assessments for PBL are those that actually assess students in real world, as they're addressing real world problem tasks. In order to promote cognitive apprenticeship, the teacher can help model some of the behaviors they want to see, as well as help students to make known kind of that hidden knowledge or some of the processes of their learning, so that the other students can learn from them. This process, or this problem-based learning, was initially low tech, but now there have been various means of high tech PBL. There's many different types of cycles, all for different purposes. Some extend with phases of abstraction and reflection. Others use are highly dependent on different types of artifacts supported by technology that can happen essentially anytime. And there's even one that combines knowledge creation. So that's Nanaka's model for knowledge creation that comes from organizations, and the PBL model. Limitations, this is currently a work in process. Our sources are restricted to 2 journals, and some of these results may not transfer well as they come from research contexts, and these can include things like having customized technologies, funding, research supports, and different classroom constraints. Our next step is to complete the comprehensive synthesis, and that will include a detailed collection of information and mapping and visualization of demographic information, the methods used by each one of these, the technologies, the outcomes, and theoretical and technological contributions. So yeah, thank you very much.
Okay, thank you, Joel, Rubaina, and Garrick. We will wait for questions after all 3 presentations are done, because I think they tie in really well with each other. I did ask you to put any questions you may have right away. You know, sometimes we have a thought and we want to get that in writing. Feel free to put it in our chat and we will come back to it with our presenters. Okay, our second presentation in this session is by Chao Zhang and Bojana Krsmanovic. Now it's titled Understanding Instructors' Practices of Active Learning from Their Activity Design and Scripts, Lessons from the Field. Chao is a PhD student from McGill University. Her research interest is in instructional design of active learning classrooms, classroom discourse, and student agency. Bojana is a graduate student in education technology program and one of the big forces behind our conference here. She's being very humble. She is interested in active learning and instructors' practices, as she was introduced to the field closely while working with Salty's team for the past 1.5 years. So over to you, Chao and Bojana.
Oh, thank you so much, Preeti, for the introduction. And I guess we're not going to start our presentation. So I'm going to just present it here. So Burron, you're muted.
Sorry, there we go. I fixed it. Thank you, Preeti, for this wonderful introduction. I would just like to say that even though today this study is going to be presented by Chao and myself, the list of authors also includes Preeti and Elizabeth Charles. To begin with, I would like to present you with the overview of our talk today. We will first be covering the theoretical framework for the study. Then we'll be looking at the research question, followed by the methods and the results. Next, we will be going over the discussion and directions for the future before wrapping up with the study limitations and references. I will now give the virtual floor over to Chao, who will open by talking about the theoretical framework for the study.
Okay, thank you, Burron. Okay. Sorry, I just got a message from Zoom and I don't know how to respond to it. I just put it aside. Okay, I guess I'll just quickly present a brief literature review to situate our thinking like within this paper. Actually, what Joe and Garrick and Rubaina just presented actually started a very solid kind of literature review, which also our study kind of based on. So a lot of things probably we listed here, we can go over very quickly. So as Joe presented this historical development of changing views on teaching and learning in both of the communities, both in active learning, I guess probably more populated with practitioners and also the learning sciences, populated by the educational researchers. And so me, myself, I also come from a learning science background. So as as Joe introduced, this kind of field of research primarily focused on how people learn. So so a quick literature research on this kind of field, it seems like our understanding about how we learn better actually shifted from behavioralism to cognitivism to constructivism. So it's being apparent like now currently at the stage of the constructivism where teachers are really curious about to know how we better support students to giving them the opportunity to make sense of the knowledge and how to link that to their personal life and how so that they can construct their unique meaning out of the knowledge and in turn to develop I guess a skill set so they can use in the future learning or future life if it's possible. And because as we changing our views on the learning, I guess no matter we are educators or practitioners or educational researchers, we all feel like actually this shift of focus also happening in teaching as well. So I guess most of us, we being familiarized with the teacher-centered and student-centered kind of terms, which kind of slightly shifted the spotlight from what teachers are really doing in the classroom to how we're going to help students so that they can achieve their kind of understanding, they can achieve their learning more better. And so that we hear the calls coming from the educators and researchers, especially in our post-secondary level, so that we have the term kind of active learning being very popularized for the recent decades. So we call for, okay, let's do less lecture. So let's have our students, less listening and having them more kind of engaged in the experience more, to do more, to engage in the thinking process, the learning process more, instead of just being presented with the knowledge product. And luckily, what's been really exciting is the research also shows, actually also part of the Garrick also mentioned, those are students actually can benefit from those kind of like active learning type approaches, teaching approaches and learning approaches. Their learning, their understanding get deepened and their performance got, achieved better. So that's quite promising to kind of for us as a kind of educators to know, because that kind of links how we teach and how we learn better together. So because we keep mentioning, active learning, and I guess we all been familiarized with the term, but essentially, what does it really mean? So from the early kind of literature, from the active learning community, from the Bonwell and Elson in 1991, it's almost like 3 decades ago. So basically the term being defined quite in general. So we can see like student must write, read, discuss, engage in problem solving. Most importantly, has to be higher order thinking tasks, involve analysis, synthesis, and evaluation. So those type of tasks are probably hardly to be, reviewed if students are just asked to kind of listening to the lecture. It's very hard for teacher to actually, assess or, assess the level of students at and provide the in-time feedback. So that's where the active learning part becomes a very popular thing. We want them to be active in the learning process. But what does it really mean by active? So Chi and Wiley, I guess, those are the kind of prominent researchers from the learning science, from the cognitive science field. They are bringing this kind of idea about cognitive engagement. They were trying to kind of link between the education, the research community and the active learning community, trying to say, okay, what do we mean by active learning? Is actually to ask students cognitively being active. So they kind of develop a model called ICAP model to capture, the different level students can get actively engaged when they learn in the classroom during those all kinds of learning activities. And as Joe and the team presented, actually the active learning becomes an umbrella term, encapsulates a lot of different approaches, could be like inquiry, could be like argumentation. All of them sounds very interesting and exciting. But what's the core here, Chi and Wiley argues that is the mechanism, is no matter you're doing problem solving, no matter you're doing argumentation or in the inquiry based, the core here is to have students cognitively, I guess, being active, being activated in the learning process. So in order to infer student cognitive engagement, I guess as a teacher, we all know it's hard to tell at which stage student at. They seem to be engaged, but how should we know? Because it's totally in their brain, right? So Chi and Wiley proposed a proximal kind of indicator is by their overt behaviors. So they have, so that's where the ICAP 4 letters represent the 4 types of behavioral engagement. Actually, it's passive, active, constructive, and interactive, as you can see here. So they're trying to capture, our students just, passively receiving kind of information in a reading, or are they asked to, highlighting or summarizing the key points, or are they asked to teach each other, about what you just read, or are they asked to reflect on how the reading related to their personal experience or life? So it's a different kind of levels of engagement with the learning material that leads to different levels of learning outcomes. And also, so it really looks like a promising kind of model for, I guess, for practitioners and also for researchers to kind of explore it together to see how that really going to, help the practices and also further to help our students learning. However, it's a case that since it's a kind of, it's a new model, but actually it's built on a history of, learning sciences kind of research findings. But most of the work has been done at the K-12 level. So it's really, so it's kind of lack of understanding how the post-secondary level really respond to those kind of models. So that kind of the gap identified here is we're really curious about, since we have a bigger active learning community at the post-secondary level, and we kind of start wondering how that kind of theory applies to the population here. So that's kind of leads to our first research question. And since we've been talking about the student engagement, and student engagement, I guess we all know it's closely connected to student learning, either outcome or their performance. However, as we as teachers or practitioners all know, like in the real life, in the real classroom, that student engagement is not just a cognitive engagement. It actually, it's a multidimensional construct. Well, a lot of us, we design activities for students to engage cognitively, but it's sometimes it's hard to do. So we probably need to doing some indirect kind of prompts by engage students emotionally or motivationally or other kind of aspects of engagement. And also there's a on the other side of the research kind of community, they do also interest in the same kind of ideas. And they suggest actually in designing our learning activities and in designing our learning classrooms, we can do some tweaking or we can do some, specific plan so that we can engage students or we can capitalize on students' cognitive kind of needs or psychological needs. So have them, trigger their interest, making them really, get wanting to get involved deeply into the learning work. And again, like this sounds very promising. However, a lot of literature we discovered is also kind of focusing on the K-12 level and the lower grades. And we were wondering, like, is it still, a matter like to our post-secondary secondary level? Does our students, they just engage like automatically, so we don't need to worry about it? Or is it actually, it's also a case bothering us and our teachers already have, different ways to address that? So that becomes our second research questions. So the exploration, I guess, a brief exploration of the literature leads us to our two research questions. Is the first one is, to what cognitive level specifically do those kind of learning activities designed by the practitioners in the field intend to engage students? And the second question is, in what ways do those activities do they promote student engagement, like in general, not only focusing on the cognitive level? And I guess now we're going to have Bojana to present to you our methods.
Yes, so for the purposes of this study, we were looking at the collection of activities from practitioners in the field, which was shared with the community on a public website. The website was selected as the main data source, first because of its broad collection of learning activities contributed by post-secondary instructors from various institutions, and second, because these activities claim to be representative of active learning instruction. Our data inclusion criteria revolved around 3 points. We looked at the activities that, as you can see, were new, meaning that the students had not worked on previously. They had some instructor-provided materials in terms of activity instructions or worksheet questions. And the third one, they fit into a one-class period as opposed to running over multiple classes and sometimes even over the course of semesters. As
you're
for
a little
data,
over, sorry, Bojana, you're a little over 12 minutes.
Perfect, thank you. As for data sources, you can see that 66 out of 154 activities contributed by 33 instructors, representing 12 fields of study, with 80% of these belonging to the STEM disciplines. Each learning activity is described on a separate web page containing an overview of the activity, its objectives, lists of possible challenges associated with the implementation of the activity, and a corresponding list of coping tips. Some activities also come with activity materials, which were available to the public as downloadable files. Examples include teacher instructions, scans of reading, activity worksheets, etc. So we came up with a coding schema for active learning activities using the cognitive modes of engagement adapted from the ICAP framework. In this table, you can see the codes in the first column, for example, passive, active, etc., and the definitions in the second or the column to the right that we assigned to them according to the literature to be applied to the rich data we had access to. For example, you can see here how mode refers to the students reading text. Passive mode, it refers to students reading text, watching videos, or listening to lectures, etc. So to exemplify this, just to give you like a taste of what that looked like, Chao, if you can change the slide. So in this first screenshot, you can see the process of coding the data. Our unit of analysis was the tasks in learning activities. Each activity is made up of multiple tasks performed by both the students and the instructor. And we collectively segmented the 66 activities into 166 tasks, and any differences in segmenting activities was resolved through discussion. In the second screenshot, you can see how, you can see it here, how based on the coding on the task level, we generated the overall engagement mode for each activity using the highest level of engagement to determine the mode. Chao?
Oh, thank you, Rana. So based on the kind of coding process and coding schema, the methodology we used, so that leads to our results. So I guess that's the fun part, because we're curious about, that's the theory, that's the theoretical kind of framework provided by the research kind of community. How, if borrowing that as a lens, how we're going to, see the practitioners kind of designing and scripting their learning activities, which are available to the whole community. And the results, so make a table. So in total, we have 66 activity as Bojana introduced. So actually, majority of them, we can see it's actually fall under this interactive, which is the highest level of cognitive engagement, and a little bit kind of scatter around the rest of kind of 3 engagement levels. And also, yeah, it's almost like 75% of the entire activity, and almost like 0.5% of the tasks. In terms of the social plan level, because the Chi and Wiley's kind of framework only talks about this interactive level in terms like its students asked to talk to their collaborate with their peers to construct kind of knowledge together. So we want to look a little bit deeper into like when students work with their peers, in what kind of format are they, doing a whole class format, or are they doing a more like kind of small group, pairs, or in a kind of 4 or 5 students. So as we can see here, so it's a majority of them, I think it's a kind of like it's kind of based on groups. So I'm sorry, I'm just trying to see how where is the forms, and some of them, they fall under like the classes. So if it's coded as individual, and clearly it's there's not kind of interactive kind of component. So either students, they're alone doing this kind of like a more active level, or more themselves construct, but not kind of sharing with the other peers. So
Chao, I'm going to ask you to start winding up soon. So we can come back to this in the discussion, perhaps.
Absolutely. Thank you, Preeti. Yeah. So I guess just quickly, what this kind of tells us is, I guess most of the activity we're being examined is actually designed in a way to kind of promote this higher level kind of cognitive engagement. And for the second research question, we want to ask, so in what way they promote student engagement in general. And we identify 1/3 of the activities, not all of them, 1/3 of activities, they explicitly kind of have the statement about, I want to, in what ways we are going to promote student kind of engagement in the activity. So we identify actually 4 ways. The first one is kind of provide students a sense of autonomy, so letting them to choose problems at their own paces. And the second one is to encourage students to appreciate the value. So it started to kind of, seeing the connections and why I'm doing this to get more purpose. And the third one is to trying to connect students with their peers to foster this kind of collaborative or community kind of sense, to have them more engaged like socially. And last one is kind of to build in those kind of game-like elements in the classroom, in the activities, so that there's a kind of sense of excitement or competition being aroused, so that to engage students more, I guess, extensively. So a quick discussion, I guess the findings of our current study, as again, it's a kind of still ongoing work. It's kind of, now it's a preliminary kind of analysis, shows that most of the activities and the instructors we examined, like available to the community, is actually they does a good job in this kind of designing those kind of active learning class activities that kind of provide us, they could be served as valuable resources for, our kind of collective knowledge, collective resources, and probably more can inform us in terms like how we learn together as a community. And the second one is it's about the future directions, because a lot of research also point out, there's a huge gap between, the activity being designed and the activity being enacted. So even though when we claim this activity can want to engage student in this way, but maybe in the reality, student responded in another way. So I guess one of the major future direction for us is to not only looking at the design, but also looking at how those activities being implemented and what's the real kind of, I guess, reactions happening there, so that we can decide on, what are the better ways to help, help teacher design, and what the best way, in the design we can avoid trying to, things just happening in our mind, but not really happening in the reality. So,
and yeah, I'll just be very brief to conclude the presentation. We recognize the limitations of our study, and there are two major limitations to the study. The study only examines active learning activities created by practitioners in the field, which are shared with the particular community on a public website. Therefore, this might limit the overall generality of these findings. And the second one, for some active learning activities, we could not find complete description of the activities on the webpage or the instructional materials prepared by the practitioner that is author of the activity. So to address this limitation, we chose to acknowledge the incomplete information in coding by assigning specific codes such as non-passive and non-applicable to avoid biased subjective interpretations. And that's it. Thank you very much.
Thank you.
Thank you. Thank you, Bojana. Thank you. We can come back to any questions you have with respect to their presentation, or the first one right after we hear from Michael. So our third presentation of this session talks about how teachers implement these active learning typologies of orchestrational flow. Michael Dugdale, as many of you know, is a physics teacher at John Abbott College. He's just finishing his, 15th year. So in addition to teaching, he's also been involved with education research with Liz Charles's group for the last 10 years. And he's also currently working in R&D in AI with Jacob, a college community technology transfer, CCTT Center. Finally, he's finishing his PhD in didactics. It's a discipline-based learning sciences at the Université de Montréal. Michael, the floor is yours.
All right, thank you very much. Let's see if I can manage to get this working. There we go. Is that visible?
Yes, it's great. Thank you.
All right, great. So yes, my name is Michael Dugdale, and I'm here representing a much larger group that's even mentioned here, but it is a group that's led by Elizabeth Charles, and we've been working together for a long time. And this is actually, we're just going to report on a very, very small corner of a much larger study that we did a few years ago. And in fact, this part was even cut down from a longer talk. So there are many details. If you have questions that I'm leaving out, if you have questions, by all means, happy to answer them. So we were really looking at, the title's a little bit ambitious, how teachers implement active learning, typologies of orchestrational flow. What we were really wanting to do is, rather than come at it from the learning sciences side, come at it from the active learning side. What are teachers doing in the wild? Can we categorize it? Can we create some sort of typology of what we see? And what can we learn from that? And we're basically trying to get at the question, what does active learning mean? And so when we talk to a practitioner, that can mean a lot of things, and it usually involves elements that are high on Bloom's taxonomy, or elements high on ICAP in some way. I'm going to come up with in practice. I'm going to make a little bit of a dangerous statement and say, in practice, it actually is something a little bit simpler. So what we went in with was a question: what does active learning look like in a classroom, in actual classroom enactments? And what might we learn about the types of components that allow teachers to sustain their use of active learning practices? And for this little part of the study, we considered the population of CEGEP teachers. And for those of you outside of Quebec, a CEGEP is much like a junior college. Students don't do K to 12 in Quebec. They typically do K to 11, then do 2 years at a cégep, a collège d'enseignement général et professionnel, which basically is a for a lot of our students is pre-university. And then they will go on to immediately into effectively the second year of university. So the typical degree is 3 years after cégep. So it's sort of like the grade 12 as well as the first year of university. We sampled from our local network, and that involved, in our case, 19 teachers from the Anglophone cégeps. All of them exhibited a serious commitment to employing active learning strategies. So this wasn't a representative sample in any way, or it's representative of teachers at Anglophone cégeps who have exhibited a heavy commitment to active learning strategies. To operationalize that, it was a voluntary selection. Would they teach one or more of their courses in a classroom devoted to active learning practice? We got teachers from physics, chemistry, biology, mathematics, psychology, history, humanities, and English. And the class sizes ranged from 15 to 47 students. And none of the teachers were sort of brand new to teaching in active learning contexts. The minimum, we had the least experienced teacher had 5 semesters of experience in teaching in an AL space, and the mean was about 9 semesters. Now, these AL spaces involve both high-tech spaces and with multiple smart boards and orchestrational tools of that nature, as well as low-tech AL spaces where you were really sharing whiteboards and the like. It was a case study design based on mixed methods and ethnographic approaches. I'm only going to report a little bit on the mixed methods material here. And for that, we were really coordinating classroom observations, which included field notes and video recordings, and some self-reporting instruments called the PIPs. So talk a little bit about what we found in this little corner of this study. Here's our, here's the big graph that we end up with, that we could actually classify and cluster teachers around how they implemented active learning by looking at number one, the percentage of class time that they devoted to group work, and on the other axis, how long those enactments were. Were they short and repeated, or were they basically a long class associated with group work? There are 4 clusters there, and I will describe the 4 of them. But I really just wanted to touch on this, say, somewhat controversial statement. Active learning is a big idea, but when it comes down to it, when you look at it, about 80% of active learning activities, of student-centered activities, about 80% of that was devoted to group work. And so, and we saw this when we looked at the time allocation and compared that with sort of the teachers' approaches in the class through the self-reporting in the PIPs. What came through is, what does active learning mean to these teachers? It means I'm doing group work. And that was not entirely unexpected, but the strength of that signal was a little bit surprising. So if we take a look at the class time spent on AL, we can see in this group of teachers, they're spending more time on group work than they are in lecturing. And that really sets them apart from sort of the standard story of higher education teachers. So they really did exhibit a commitment to active learning practice. And we can see that here, sort of another representation of the same thing. The percent of time spent on student-centered activity, almost half the teachers were more than 60% of the time devoted in the classroom to student-centered activities. So what we take away from that sort of setup is that the teachers that we looked at were making heavy use of active learning strategies, and that the majority of active learning enactments involve group work. And that was ended up, for the rest of what I'm going to say, group work is being used as a proxy for student-centered activities. So when we went about it, we started looking and coding what was happening in the classrooms. And through use of video and a coding scheme, we were able to sort of measure and compare across courses. So for instance, we call this a pedagogical pattern, this global time allocation that's happening in the classes. And we compared two courses here. One of them is a chemistry course enacted by one teacher, and another course which was a physics teacher, and was one of our physics groups. And we could see that those pie charts, that allocation of time in a global context, looked pretty similar. And we might be tempted to say, well, it looks like they're doing things in much the same way. And if you take, however, if you take a look at it on a different slant and actually mapping out what is happening moment to moment, you can see that there's a difference in the switching between different types of activities. So for instance, in this case, the chemistry teacher has very long student group work sessions, whereas the physics teacher on the bottom, and those are indicated in blue, the physics teacher on the bottom is these short staccato-like interventions, much shorter, but they're repeated, they come back to them. And so there's a different interplay between group work and then focusing on the teacher for a moment for the physics class, compared with the chemistry class where there's a setup, and then the students are anticipating to, or expected to work in groups for long stretches at a time. And so when although the global time allocation looked similar, when you sort of look at the way that they're orchestrating those active learning sessions, they did show up to be quite different. In contrast, the global time allocation for these two courses was shown to be, looks quite different. However, they had very similar sort of flow to the way that these segments of group work versus teacher intervention were arranged. And so these would look similar in that way. And so we wanted to look at ways of quantifying that, of categorizing how these flows work. We looked at a number of methods. One of the things that, one idea just on the side that fascinated me was the notion of using autocorrelation functions to take a look and see. There was some interesting work on length of scenes in blockbuster movies and how their autocorrelation functions look. That didn't take us anywhere, but what did was actually just taking a much simpler view of that and splitting it into two axes, for describing the types of enactments that we saw. One of them, the horizontal axis here, is the percentage of class time devoted to group work. So, from the far left to the far right, you're moving into cases where the teachers are really doing more, devoting more and more of their time to student-centered activities. On the vertical axis, we're taking a look at the average length of those group work sessions. And those could be very long or very short. But to that, then we applied a cluster algorithm to actually take a look and see if we can separate those. And when we did, we actually started to see not only, sort of cluster differences, but when we looked at it, what's happening in cluster one and who are the teachers in cluster one and who are the teachers in cluster two, there was a qualitative feel about their enactments that was evident. And so that gave us a little bit of confidence that we're looking at something that does actually capture some of these orchestrational differences within the teachers. I'll take a moment just to say that things like these graphs that had excuse me, the graphs that had sort of those short segments versus long segments, they were largely stable across contexts for a given teacher. So even moving a teacher from a high-tech active learning classroom to a low-tech active learning classroom, we actually saw that those patterns persisted, and it seemed to be something sort of intrinsic to the way the teacher has formulated how they do their job. So in this case, cluster 1, you'll see that's at the far right. This is a group of teachers who engage in a lot of active learning. You can see the numbers along the horizontal are quite high. They devote a lot of their time to that, but they're using fairly short, interrupted active learning sessions. And in fact, some of the teachers make use of that deliberately. They design a group activity, not with the intention necessarily of finishing it, but giving it an amount of time and stopping once enough had been accomplished, not necessarily the whole task. Cluster 2, you notice, is sort of the comparison there. They had these very long group sessions, and these would be cases where the students were involved in things like problem-based learning, which really require a lot of time, a lot of contiguous time be spent by the groups to actually advance. In cluster 1, for instance, you would see a lot of cases of problem sets and individual problems and teachers intervening as we go there. Clusters 3 and 4 were teachers who are, for whatever reason, a little bit less, devote a little bit less time in looking at the groups and in examining their experience. We found the cluster 3 are teachers that seem to be in a transition towards either a cluster 1 or a cluster 2. Cluster 4 actually turned out to be a couple of teachers in one particular classroom that involved some particular difficulties, and they fell out a little bit of the cluster 1 to cluster 2.
Okay, Michael, perfect. I was just going to give you a time warning. Amazing.
So I just wanted to acknowledge, this was, again, part of a much larger study. It was funded partly by a Perea grant from what used to be known as le Ministère de l'Enseignement Supérieur, or MERSRS. It was also involved a SSHRC, pardon me. I had my timer going too, and but the faculty that we studied, we drew them from Dawson, Vanier, and John Abbott colleges, and we would not have been able to accomplish any of this without the very hard work of our research assistants. At the top of that list, of course, is Chao, Zhang, who you heard from just a few minutes ago. So thank you very much, and here we are.
Okay, thank you, Michael. So we've heard from our three presentations, and now I'd like to invite Professor Jim Slotta to discuss. He's our discussant for the session. So Professor Jim Slotta is a professor and President's Chair in Knowledge Technologies at OISE, Ontario Institute for Studies in Education at the University of Toronto. Since 2005, he has led a team of students, designers, and developers to investigate new models of collaborative and collective inquiry in K-12 science, including powerful new roles for technology-enhanced learning environments. He has a background in physics and cognitive psychology, and he's developed a pedagogical model known as Knowledge Community and Inquiry, KCI, in which students explore, investigate a phenomena or issue within a carefully scripted and orchestrated sequence of learning activities. Jim, the floor is yours. Our session does go till 5 o'clock, but perhaps we could continue the discussion if it goes on.
Let's unmute. That happens. I have to confess, I came in not completely at the beginning of the session. I feel like Hermione Granger in one of those books where I had to do two things at once. I was actually running a workshop that finished at 4:30. But that said, I know and I'm very familiar with the first two presentations, and I came in time to see Michael's presentation. So I have solid ground for making my comments, and thank you very much for inviting me to this, and welcome everyone to Saltese, one of our favorite conferences. I see a number of people from the Encore Lab here in the group. I'll share my screen because I'm gonna go look at my notes anyway, as I took earlier today, and I can go through them and you can see what I'm seeing. And then hopefully we have time for a question or two. So I did some thinking about each of the papers. I did go through all their PowerPoint slides as well. And just my initial reactions and thoughts. Okay, so first for Joel's paper and Garrick and Rubaina, that first of all, terminology is an issue, as we saw in the web search, in the scoping review, and when you go find even papers that are referring to certain things like inquiry or design or any of those, that it's really problematic. Even when you looked for active learning and couldn't find explicit mention of that, that was striking, and probably the big finding of your whole paper, honestly. That and it occurs to me that by naming things vaguely, you know, we kind of almost guarantee that they're not going to be nuanced, because people just don't even know. I'm feeling that way with the word critical these days, right? Another interesting thing that I think came out of that paper for me was that even in the learning sciences papers, which is saying something, the specific mechanisms or the cognitive processes that underlie those learning designs are not always well described. I could call them under-described. And then finally, that reviews by their nature, but particularly on something like this that's really broad. It's like active learning and it's called by different names, and we're going to look inside a literature that's already a multidisciplinary, you know, community, that you're going to be missing some big pieces. And I thought to myself, I'm not actually sure what a scoping review is, but it seems like it's more than what you said in your slide, which was that it kind of gives you basic information or whole information, or I can't remember what you, but it also seems like a diagnostic instrument. So you could use it to, I was thinking kind of like a mining survey to find out where you should go deeper and where the action is, right? But also maybe where am I missing something? Like I know that there's been work on this and it's not showing up in my scoping review. So those are all initial reactions to that paper. And for Chao's paper and that group, I'm very interested in this project. I've followed this project. First of all, just kind of starting to you know, recognize that there's a kind of selection bias, that we began with these 66 designs already coming in as kind of a recognized active learning designs. But that's great, because that's sensible that you would start there and try to capture and characterize those. One thing that wasn't immediately clear, I apologize if it was clarified in your talk, was that I think these activities varied in their grain size. I'm not sure what that scope was. Were some of them sort of partial periods and some of them whole periods and some of them multiple periods, class periods? And that might account for the difference in how they were coded. If it's a whole class period, I can imagine, like you said, all 4 of these things would happen at some level. And if it was just a lesson, it might not get beyond a certain, you know, or just a partial lesson, it might not get beyond a, you know, constructive level or something like that. So the kind of density of these codes would be something to think about there, and maybe even normalize that and create a normalized measure. I like to think about a recipe metaphor. I mentioned this to you before, but the idea that there's kind of a food pyramid, and, you know, if ICAP is the framework you're using, that I is kind of the goal, but you really you couldn't completely teach in the I level. So you'd need to have some P and some C and some A. And kind of trying to how to understand the balance of those, but also when they occur, in what order and sequence, and what are the kind of, you know, you're building these analyses from the practitioner data. So you're trying to find out how the working world is actually using these kinds of activities effectively. So that's almost better than a theoretical perspective because it's sort of proving itself in practice. Third, just that any of these kind of broad assignments of some are like one thing and others are like another thing are pretty risky to do without a deeper representation. So I would just kind of encourage, and I know this is labor intensive, but interviews with instructors and document analysis and maybe even a kind of visit to the classroom when it becomes available to really get a more clear characterization of those categories. And I'm not sure that you got everything from the instructors. Trying to keep moving fast here. Michael's paper, I really think this is interesting. And the fact that activity equals group work makes you wonder, right? Why is it that group work is biased toward an activity in active learning design? Why is it typically more active? And it seems intuitive to the instructors as well, right? So I was thinking this is probably the rare case where causation is actually very clear here. They chose the group work because they would manifest active learning. Kind of can't have it almost without it. So that was really cool. And then the average duration of group work, I think, is a great principle for clustering because it does kind of speak to what's being done in that group work and when is it being done. So I'd be interested in a deeper kind of thought about those clusters, including that kind of sequencing. Does it, do the people that use long group work do it toward the end? I love that difference between the chemistry and physics course. The way it comes across in your presentation is like it's a difference between chemistry and physics. I know you don't believe that, although you are a physics person, so maybe you do. But it's quite possibly more about where they were in their particular course. Like they might actually have very similar courses, but you caught this one on a Tuesday and this one on a Thursday, and it ended up looking quite distinct because one of them was in a review segment and one of them was an intro and more, a different point in time. Or it could also just be, differences between the teachers. So that if you had one teacher that taught both chemistry and physics, they would look quite similar. So it's a really interesting approach, but I think it's important to remember those differences could be from a lot of different reasons. And then finally, just to close, there is a really great battery of input of crosstalk between practice and research that's related to active learning. I should have started with the need for researchers to look at practitioners because honestly, that's where this session is coming from. I'm just, as a researcher, I'm hoping that my work becomes available to practitioners, and I know that Saltese is a practitioner largely audience, so I just think it's important for them to sort of understand learning as something that can be investigated. That there is a science of it. Many of us here in my group are learning scientists, right? That's not quite the same as educational research. We have some principles for designing active learning, reflection, collaboration, design thinking, negotiating shared representation, discourse around visualizations. So there's work that's been done. It's not the same as instructional design. And that even what I would call informal action research on your parts, like taking risks, trying new things, that this is a way to deepen and kind of grow in terms of how and what we're how we're teaching and what active learning means for us, for our students. So you can ask things like, what would you like to see happening with your students? Right? That's a simple kind of actionable question, like in their thinking or in their discourse. What would constitute deeper learning for you than what you've been getting? What kinds of discussions are happening in class, and what other kinds would you want to see? And that by asking those kind of questions that you could come up with very specific things to try out, and then you'd have evidence to look back to see about your success. In parallel, I think that researchers need to be driven by practice that's working. That's actually one of the great things about Saltese and about active learning more generally. It's a practitioner movement. People are just starting to try new things, and some of these things are working amazingly well, and that's becoming, documented. And I think researchers need to look at that. They can help us understand the deeper context of learning. We could get involved in co-design partnerships. We can reveal important variables around engagement or instructor practice, and patterns like what we're seeing in this session. So in just closing as a broad field, I think there should be a sense of kind of pedagogical grammar where, for example, one design would be grammatically, that's the thing about grammar is you sort of know when you're violating it in music or in words. And I think in pedagogy too, and I think as a field, we can come to something like a kind of a grammaticality. And I have a typo. So on that, I'm going to end a little bit late, and thank you for staying. I'll stop sharing. I can share these notes, of course, but thank you. And if we had any time for you guys to ask questions to the authors would be the best thing.
Thank you, Jim. Any burning questions or comments? Because I know we're a little tight on time, but anything that you'd like to ask Jim or any of our presenters? Yes. Okay. All right. So we can continue this discussion on GatherTown. The day is not done. Salties for the day is still going on. You have a fun end of day event on the rooftop of GatherTown. It's a place to get a sense of Montreal. Liz is here. Liz, are you going to give us a welcome to GatherTown pitch?
Oh, absolutely. And GatherTown suits Jim and your group right out. It's exactly up your alley. We'll be doing trivia games, winning prizes, talking about Montreal, looking at the view. Come see. There's a rooftop observation deck.
Okay.
Yeah, just hurry up and get there. There's live music.
Is it happening now? Is it happening now?
It started. They're warmed up.